Here's our review for our Chapter 1 test. The first one says to, using this diagram over here for 1 through 5, name a line that contains point C. You can name a line with an italicized letter on the end, but you have to use the word line. So that could be line T, or you could say use 2 points on the line. You could name it line, and then you need 2 points on the line, PD, which could be reversed, or line DC. Any 2 points on the line can name it. Name the intersection of lines M and T. Where they meet, that's what intersection means. So where they cross would be point D. Right there. So the answer is D. You can write PT, point D, or the word point, or just write D. Name a line that contains point E. Point E is down here. That would be line EF, or you could call it FE, line EF, FE, or line with the word and the P. So P's at the end there. Name line M another way. You need 2 letters on the line. So it could be line RD, it could be line DV or line RB. Any 2 points on the line, but you need the line symbol above there. Name 3 points that are collinear. Collinear means in a line. So I could do P and D and C, or I could do R and D and B. How many planes are shown in the figure? A lot of students miss this problem because they count the bottom plane twice. This bottom is part of plane A. Okay, so all of that is the same plane. The rest of the planes consist of the top, okay, and that's 2 so far. You got your plane on the left and the right, so that's 1, 2, 3, 4 so far. And then you got your back and front. So that would be 6 planes, front and back, left and right, top and bottom. So the answer is 6 planes. Name a point that's not coplanar with Q, P, and N. Q, P, and N, the ones that's coplanar with it would be R. So a point that is not coplanar with Q, P, and N would have to be something off of the plane that's on the left. There's a lot of answers to that question. So it would have to be maybe W. Okay. They aren't in the same plane as Q, P, and N. T is not coplanar. S is not coplanar. M, X, okay, those are all not coplanar with Q, P, and N. Okay, name a point that is coplanar with S, T, and W. Coplanar to S, T, and W, and I'm going to erase this thing just so I can color again if I like. The plane that contains points S, T, and W is S, T, W. You don't want to just color a triangle. You want to continue that on. So it would be the whole left side of the figure. Therefore, what is coplanar with S, T, and W would include the points M, X, and M. So X or M would be the answer. Name the intersection of plane W, P, N. I got to first find where that plane is. W, P, N. That's the front. Okay. And the plane that contains points X, S, and R. X, S, and R. Well, that's the bottom. So if you look at the bottom plane, where does it intersect with the front plane? And that would be line MN. 2 planes always intersect in a line. It can be called line NM as well. The intersection of 2 planes is always a line. Well, number 11, we've got P to S, which is the entire distance across, is 18. And R to S is 6, and then it's asking P to R. Well, we would do 18 minus 6 to get 12. And that would be in centimeters. The next diagram, P to R is 3 inches, R to S is 1.5 inches. So what's P to S you would add, and that would be 4.5 inches. 13, use the number line to find HR. HR means the distance from H to R. To do the distance from H to R, you take the larger number, which is the R, 7, and you could count to H, or you could count H to R. But the easiest way is to do the larger number, max, 7 minus the min, 7 minus -5, you subtract to the distance, which would be 12. From H to L, 1, 2, 3, if you want to just count it. Or max, -2 minus -5 would give you -2 plus 5, which is 3. From L to M, M is the larger value because it's to the right, so that'd be 1 minus -2. You take the coordinates of L and M and subtract, and then take the absolute value. If it comes out negative, you change it to positive. So 1 minus -2 would be 1 plus 2, which is, of course, 3. And you could also verify that by counting 1, 2, 3. Find the value of the variable and PR if R is between P and Q. First, you should sketch that R is between P and Q. So P and Q are on the ends. R is between them somewhere. Doesn't mean right in the middle, so I'm just not going to make it look like that. P to R is 4A. R to Q is 7A. And then all the way from P to Q is 55. So that would mean that you could add PR plus RQ to get PQ. That's our segment addition postulate. 4A for PR plus 7A for RQ would equal 55. Now we have an equation. That's 11 times A is 55. When you combine your like terms, divide both sides by 11, and we get A is 5. And then P to R would be 4 times 5, which is 20, and that would be in centimeters. 17, we've got that ray QS, which starts at Q and passes through S, is an angle bisector. It bisects angle PQR. Angle PQR is this opening. Okay, and that has been cut in half. That's what bisect means. So we know that angle PQS is congruent to SQR. Find the two measures not given in the diagram. Well, SQR, it says what's R to Q to P? Well, that'd be 73 twice, because this is 73 too. That'd be 146 degrees. And then SQR is 73. Use the distance formula to find the distance between the pair of points. The distance formula, oops, don't like that pen. Distance formula is the square root of the difference in the x's, x2 minus x1 quantity squared, plus the difference in the y's, y2 minus y1 quantity squared. I suggested to students that they fill this in. So your x1, x2, so -4 minus 7 quantity squared plus your y1 and y2, 1 minus -3 quantity squared. I told students to type this all in on their calculator. Say you didn't do that. That would be -11 squared plus 4 squared. This has to be positive. When you square a negative, you get a positive. So it's the square root of 121 plus 16. 4 squared is 16. Adding, you get the square root of 137. You can grab the calculator and type the square root of 137. Okay, so second square root 137. Or you could type all of that stuff in parentheses right on the calculator. Should be getting 11.7. All right, and then it said find the distance in part B as well. So the distance between these 2 points, 0, x value minus negative. I don't know why I made a comma there. Excuse me. 0 minus negative 3 quantity squared plus 11 minus 6 squared. This would be positive 3 squared. You could type all this on your calculator. 3 squared plus 5 squared. Actually type all this in parentheses and you should come out with, that is 9 plus 25, which would be the square root of 34. So then you take the square root of 34, and approximate it to, say if it said to the nearest hundredth, that'd be 5.83. I went to the nearest tenth on the last one. Oh, this says to go to the tenth, so you drop that off, 5.8. Find the midpoint of the segment. Midpoint formula says take your x's. I'll write down the formula. First, I'm going to get a pen that doesn't make dashed lines. You take your x's, x1 plus x2 divided by 2, y1 plus y2 divided by 2. Students will have this on their formula sheet. So negative 11 plus 1 divided by 2. The most common mistake, a negative 3 plus 8 divided by 2. These are your x's, and these are your y's. Most common mistake is kids will just type this directly negative 11 plus 1 and then hit divided by 2 and they get the answer wrong. And that's because the calculator isn't adding and then dividing. So you need to add negative 11 plus 1, which would be negative 10. Negative 10 divided by 2 is negative 5. This would be negative 3 plus 8 would be 5 divided by 2, and that's 2.5. For this one, you're going to, again, add your x's, negative 0.4 plus 3.5, and then divide by 2. But make sure you put parentheses around it if you feel like typing that all at once. And 2.1 plus 1 divided by 2. I didn't actually do this, but that's 3 divided by 2, which would be 1.5. And that's 1.1. Oh, no, it's not. Oopsie. I added wrong. So that would be 2.1 plus 1 would be 3.1 divided by 2. So that's 1. Ugh. Why are these icky? They are. Oh, let's see. That's 15.1.5. Why am I doing this in my head? I don't know, but whatever. I like to do mental math. 1.55. So you could verify that, of course, on your calculator. 3.1 divided by 2. Okay. Next, accurately measure the angle. You should be ready, if your arrow is pointing on the protractor to the right, you want to measure the, read the outside numbers because it starts at 0 here, so 0, and that's about 56. If your arrow is pointing that side, you would read from 0 the inside numbers. I don't know whether you just got to pay attention to where your arrow is pointing at towards 0. Not really liking this protractor. I think I'm going to get rid of that one and get a different one. You always put the vertex of the angle on that where the lines are perpendicular on this protractor. Turn so one of the rays is lined up with the bottom. Now this would be pointing at 0 on the outside numbers. So that would be 120. Oops. Okay, 120. If in the figure ray GK bisects angle FGH, that means this angle is cut in half. Bisects, we need to know what that means. An angle FGH is this big angle, right? And the ray GK cut it in half. If FGK is 8x plus 14, FGK 8x plus 14, and FGH, the whole thing is 140. Find W. Well, if you know the whole thing's 140 and it was cut in half, half of 140 is 70. So each of these is 70. So we want to do 8x plus 14 equals 70. We'd subtract 14 from both sides. 8 times x would be 56. And now we would divide by 8. And that would give us W is 7. And I don't know, I used an x instead of it was supposed to be a W. Okay, plug in 7 back in here. 8 times 7 plus 14. But actually, we knew FGK was 70 degrees. And that would give you back 70. In the figure, ray TJ and TL are opposite rays. That just means we have a straight angle here. Angle 1 and 2 are congruent. So I'm going to mark that with arcs. And ray TP bisects angle NTJ. So that means angle 3 and 4 are congruent. What figure is an angle bisector? It's a ray. A ray is the angle bisector. So if it be ray TP, ray TM is also an angle bisector. Has to start with T and then pass through a point. What bisects angle LTN? And that was ray TM. If the measure of angle JTM is 4x plus 30, that's almost that whole thing. And 1 is 2x. So they're talking about this is 4x plus 30. And then this angle over here is 2x. So these would add up to a whole 180 degrees. So 4x plus 30, oops, that was supposed to be 30, plus 2x equals 180. That gives me 6x plus 30 is 180. If I subtract 30, I get 6 times x is 150. And then I need to divide by 6. Oops, grab the light colored pen there. That would be 45. Right, and then the measure of angle 1 would be, well, that doesn't make sense. I don't think I divided correctly. I'm sorry, not 45, 25. Hello. Okay, for 25. So angle 1 would be 2 times 25, which would be 50. It doesn't look like it's 50 degrees, though. So it's not to scale. Okay, this is the same diagram. If angle PTM is a right angle, and angle 2 is 2n plus 5, and angle 3 is 3n, then those two angles, angle 2 and 3, would add up to 90. So 2n plus 5 plus 3n equals 90. 5n, combine your like terms, subtract 5 from both sides. 5 times n would be 85. Divide both sides by 5. And n is 17. Name a linear pair. There are a lot of pairs that are linear pairs. In order to name a linear pair, you need to name a pair of angles that add to 180. There's a lot of different possible correct answers in this picture. If I decided to go with angle GQH to get a linear pair, I could go this way and name angle GQK. Or I could have gone with GQH and gone this way, and I would have said angle HQM. Those are just two examples of pairs of linear pairs. Name an angle supplementary to angle 2. Now I have two answers for this one as well. Supplementary to angle 2 means it makes a straight line with angle 2. I'm going to highlight the interior of angle 2. Okay, there's angle 2. I need a supplement, which means adds to 180. So I need a whole straight line. So actually there's only one answer to this. It would have to be this whole angle, right? And that would be angle GQJ. Name a pair of vertical angles. Vertical angles are angles that are across from one another and they are congruent. There are two answers for this. You could do this angle and this angle, which would be angle HQI and angle LQK. Or you could have done this angle and this angle, because they're made by two lines that intersect also. GQH. My pen's stuck. 1 second. Oh, I went outside. Angle. Oops. That surprised me there. Let me just erase a second. Back. Okay. Or it could be angle HQ. Which way? I was going GQH. And MQK. In the figure JQK, 6x plus 24, find x if JQ, that means this ray. These are perpendicular, which means they'd form a right angle. So that means that if angle JQK was 6x plus 24, it would have to equal 90. Subtract 24 from both sides. 6 times x would equal 66, and you divide by 6, you get x is 11. This one says that line AB bisects segment CD. That means these two segments are equal. So 3x plus 40 is equal to 9x plus 16. Subtract 3x from both sides. You want to do the same to one side as to the other. That will give you 40 equals 6x plus 16. Next, we would subtract 16 from both sides. I'm going to drop that down here. That would be 24 equals 6 times x. Divide both sides by 6, and our solution for x is 4. Substitute back in to CE to get 3 times 4 plus 40. 12 plus 40, this would be 52 for CE. And ED should be the same. 9 times 4, 54 plus 16. 9 times 4 is 36. 56, that'd be 52. Given angle A and B are supplementary, that means they add to 180. So these are going to be added. 2x plus 22 plus 4x plus 38 equals 180. You could have even added vertically here, 6x plus, that would be 60 equals 180, which is what this simplifies to anyway. Subtract 60 from both sides, we get 6 times x equals 120. Divide both sides by 6, x would be 20. And then substitute back in 2 times 20 plus 22 to get the measure of angle A. 40 plus 22 would be 62. Two angles are complementary. That means that they add to 90. And just draw a pair of angles that add to 90. One angle measures 26 more than the other. So if I let one be x, the other would be x plus more means to add 26. Now those both add up to 90. So 2x plus 26 equals 90. Subtract 26 from both sides. 2 times x is 64. Divide by 2, and you get 32. So one angle is 32 degrees, and the other is 32 plus 26, which is 58 degrees. 36, these are vertical angles, and vertical angles are congruent. So 9 times x is equal to 3x plus 30 would be our equation. Subtract 3x from both sides. 6 times x equals 30. Divide by 6, and x is 5. Name the polygon by the number of sides, then classify as convex or concave, regular or irregular. This is meant to be it's got 8 sides, right? 1, 2, 3, 4, 5, 6, 7, 8. So this would be an octagon. And I believe this was supposed to be a regular one. It is looking like this length is not exactly the same as that, but if they were all the lengths were the same sides, it would be regular. Since this looks longer than that, I'm going to say that it's irregular. But it is convex. Now, if it shows that the sides were all equal, meaning and the angles are all equal, then it would be regular. This one is a quadrilateral. And we're not naming it specifically an isosceles trapezoid at this time. Quadrilateral is all I need, and then it's irregular. And it's convex. Concave is dented in. This one is a regular pentagon. Regular, it has to be convex in order to be a regular pentagon. Right, pentagon. And 40, the perimeter is 120. That means you add up the outside. So we would add up the sides, 3y plus 1 plus 7y minus 4 plus 5y, and set it equal to 120. Y is 3y plus 7y, 10y, 15y. 1 minus 4 would be minus 3 equals 120. So we simplify the left side first. Then add 3 to both sides. 15 times y is 123. Now this doesn't seem like it's going to come out very nicely, does it? Did I do everything right? 7, 15y. Yep. All right. So if I grab the calc and do 123 divided by 15, I think I need to change these numbers. I wonder if I did. 8.2. Not everything is pretty. The sides then we would substitute back in. 5 times 8.2 would be 41. 7 times 8.2 minus 4. Oh dear, I just typed in on my calculator to make sure I do it right. All right, that'd be 53.4, so you're just substituting back in. Oops. And 3 times 8.2 plus 1. It's 25.6. Perimeter, this is 43. Don't forget that a rectangle has 2 opposite sides that are congruent, so you got to remember to label these as well and then add things up properly. I'm going to add up my x's as I go around. I got 2x, 3x, 4x, 5x, 6x. I got 3 plus 3 minus 1 minus 1. That's 6 minus 2 would be 4, so I got 6x plus 4 equals 43. I hope we understood that I just added up my x's, which gave me 4, 5, 6, and I added up my numbers, 3 plus 3 is 6, and took away 1, 5, and took away another 1, 4. That's where I got this. Subtract 4. On both sides, 6 times x is 39. And 39 divided by 6 is the last step. And that is 6.5. The coordinates of the midpoint and the end point of the segment. Okay, midpoint 1, 4. C is at negative 3, 6. What are the coordinates of the other endpoint? X, Y. Well, I taught the students to go from x to x, so negative 3 to 1 is up 4. Go up 4 again, so I add 1 plus 4 to get 5. From 6 to 4 is going down 2, so go down 2 from 4 and get 2. 4 minus 2 is 2. And the answers are provided on the review. We have got all the same answers, so this is just an answer key and I just went over how to do them.